Here, we are arguing about nominal strain and true strain. Let's start with thinking about the elongation of a bar. Now, the bar has length L and is stretched by dl. The strain is calculated as the elongation divided by the original length. The calculation starts with defining the elongation as dl, the original length as L, and then dl over L as the strain. Here, note that dl has d of small amount and this dl is a small quantity. So, the strain derived by the process above, dl divided by L, is a small amount of strain. We have now stretched the bar of L up to L plus dl. When the amount of the elongation is dl, the strain, which is a small amount, is dl over L. You should first understand this flow of thinking. However, what we have considered just now is only a step of elongation from L to L plus dl in a larger deformation of a bar, as shown in the illustration. The argument was stretching a bar of the length L by dl. These strains should have been defined as fraction of a strain as the equation. So, we should add d to the epsilon. You should notice that the original length of this bar is not L, but it is L0. This is the initial state in which no load is acting on the bar. From this initial state, we continue to stretch the bar. And then, the bar is now at the stage in the illustration. The bar in the argument is now in the state of length L. Then, what we want to calculate now is the strain at this stage. We can calculate it by taking the sum of the small amount of strains at each of steps we just defined. When we are dealing with a large strain, we define the strain as the sum of the small amount of strains. The equation defines true strain. The strain is the sum of the small amount of strains d epsilon or dl over L. This is integrated from L0 to L. In this calculation, since the integrated function is dl over L, we get log, and we get the strain as log L over L0, which is the sum of d epsilon or dl over L. This value is called as the true strain. Some textbooks describe this strain as true strain. Others describe it as a logarithmic strain. I learned it as true strain, but I think both can be used. Anyway, you should firstly get familiar with the concept. As a recent trend, I feel that many people call strains based on this idea as true strain. I believe that there is neither true nor not true in the argument of strain. In the case of stresses, it may be reasonable to call them true stresses based on the concept. You may recall the definition of strain that has been introduced before. That definition of strain is called nominal strain. The nominal strain is distinguished from true strain for calculation processes. There is no intention to say that nominal strain is inaccurate and true strain is accurate. Suppose we are arguing only about strain. One may recognize the nominal strain as the true strain, or others may recognize this logarithmic strain as the true strain. There is not much of deep meaning to call this strain as true strain. In general, you may understand that we call this strain as true strain to correspond to the true stress. Anyway, here, you should remember that strains described by this logarithm are called true strain. What do you think about this methodology? Some of you may feel a little bit uncomfortable with the explanation so far. It may sound a bit weird for you, taking the sum of the strains and the derived formula includes log. The point here is that the denominator in the strain is L. In the concept of nominal stress, the denominator in the strain is L0. In other words, elongation dl was divided by the original length. This calculation of the true strain assumes that a bar is being stretched to fairly longer length. Then, here, we use the variable L as the denominator, and the final calculation result includes log. If we set the denominator of integration as L0, the results also give us the same equation that defines nominal strain. The nominal and true strain, logarithmic strain, are almost equivalent at small strains. That can be easily verified by using Excel or other calculation tools. First, you should determine the value of L and L0, and then set a very small range of deformation. Now, you can compare the values of nominal and true strain. For example, comparing the value of both strains at around 1% or less, we can confirm that these strains are almost equal.